In the next two videos, I want to show two different ways of changing colors in this image. In this video, I want to use what's called a Boolean mask. In the next video, I want to use np.where. So let me remind you how a Boolean mask works in an easier example. So here I have this little one-dimensional array A, and say I type A strictly greater than 5. So this is something that we can use as a Boolean mask. It's a Boolean array, and if I do A square brackets, A greater than 5, then what this is going to do is it's going to keep exactly the values where A is greater than 5. So in this, another way to think about it is it's going to keep exactly the values where there is a true in the Boolean mask. So it looks like it's just going to keep 3. That one, and this one, okay, corresponding to this 9, this 10, and this 8. So let's see. Okay, great. And I mean, why did I choose such a random looking array? Part of the reason was I wanted to give an example of something of higher dimension rather than this one-dimensional ND array. So let me do B equals A dot reshape. And then let me do 2, I'll put it in a tuple even though I don't need to, 2, 3, 2. So you should think that this is going to be 2 rows, 3 columns, and sort of like how we often have RGB triple in the last dimension. Here we're going to have a pair of numbers in the last dimension. Okay, so I'll do that and then I'll look at B. So you should think of this as the top row, and you should think of this as the bottom or the next row. And so say I ask, where is the sum of one of these tuples? Okay, one of these length 2 inside arrays. Where is the sum of that greater than 5? So I'm going to say b.sum. And if I just do this, it adds all of the numbers together. And I want to put in an axis argument. And this is going to say, which of the dimensions do I want to change? And the thing I want to add together is, for example, this 9 and 2. Okay, and so that is in, here's the 0th dimension, the 1th dimension, the 2nd dimension. And so here I'm going to do axis equals 2. Okay, I guess I should have said first instead of 1th, but you know what I mean? So yeah, let's just look at this. Okay, great. So one of the dimensions has disappeared. Now it is a 2 by 3 two-dimensional NumPy array. Okay, and then I can ask, where is this sum? Where is that greater than 5? Okay, and now I'm going to get a Boolean array of the same shape as this one. And so up here, when I did A brackets Boolean mask, just kept the values from that kept the values where the Boolean mask was true. Here it's going to be kind of similar, B square brackets, and I want to know where is this greater than 5. But what kind of shape do you expect here? So I mean, this one should be kept. Okay, that corresponds to this true. This one should be kept. This corresponds to this true. So I mean, like, what do you think is going to happen to this? And it wasn't what I expected when I first saw it, although when I thought more about it, I can't think of a better way to do this, is it just sort of like reshapes things and it keeps the ones where it's true, and then it like stacks them all one on top of each other. So like this thing used to be 3 dimensions, but now it has switched to some 2-dimensional thing. Okay, so it kept 9, 2, kept 4, 5, kept 2, 10, and so on. Okay, so this shape here of 2 by 3, that has been lost. Okay, and now we have something that you should just think of as having 4 elements in it, 4 of these tuples. And something that's kind of fun is you might think that, okay, well, B gets completely lost in this process, but I can do something like this, and then instead of just showing it, I can replace it with something else. So for example, let's replace it with -4, -5. Okay, and now if I look at B, the old shape of B is going to be back. And everywhere where it was true has been replaced by -4, -5. Okay, and now once that makes sense, then doing this task that I listed here in our test grid, replace all 12, 12, 12 RGB triples with 0, 255, 255. That should be easier to understand now that we've seen this example. So I already have my ARR that holds these RGB triples. And so I want to know, where is ARR equal to 12, 12, 12? Okay, and then there are some sort of secret 12s that aren't part of this 12, 12, 12 RGB triple. So we need to use the all method. And again, we're going to use axis equals 2, because I want to know, were all of these equal to 12? Okay, and this is in the second dimension. And then we want to, so if we look at this, this is like the Boolean mask. And so this is saying no, this is saying no, and so on. I mean, why do we see all of these no's? Because the only place where it should be true is where we have this black color. Okay, all the others should be false. Okay, and then if we were to do ARR square brackets, this thing, okay, and then we were to look at its shape. So this is how many total black pixels there are, and then for each of those, we would see the 12, 12, 12, okay, because they're all 12s. Okay, and now I just want to do assignment the same way I did it here, where I assigned, for example, this 9, 2, I replaced it with -4, 5. Okay, in this case, I'm replacing 12, 12, 12 with 0, 255, 255. And so it's not going to work in this case. Well, why not? 0, 255, 255. I get this common error assignment destination is read only. So let's fix that. Let's say, how about C equals ARR.copy. And let me copy this, and let me replace all of these with C. Okay, that one did not give me an error. And now let's see if it worked. So what I'm hoping happened is that these black colors, they got replaced by something else. Whatever color is represented by 0, 255, 255. Let's see. So image.fromArray, see? And so here we can see that the black color got replaced by this very light blue color. Okay, in the next video, we'll see maybe a more powerful method, but maybe also a more confusing method based on the NumPy function where.